by the way, if you were gone yesterday, we're going to do today's very much similar to yesterday's, except yesterday we did arithmetic sequences, right? Yeah. And if you wanted to know, like, for instance, what the 100th term was, instead of adding 3, adding 3, adding 3, and listing out all 100 terms, you could use this formula. You need to know the first term of the sequence. You need to know the common difference. Remember, that was this one minus the one in front, this one minus the one in front, the common difference. And then remember, n was the number of the term that you were looking for. So n is 100. And this would get us the value of the 100th term. Well, today we're going to do the same type of formula for sequences, geometric this time though. And remember, geometric, it was this one divided by the one in front. This one divided, and it gave us a common ratio. Everything else is almost the same. T1 is the first term. Tn is the term that you're looking for. N is the number of the term. Like, if you want the 100th term, then n is 100. So it's the same idea. And remember, we did that first really simple one where we just plugged everything in. I'm not doing a really simple one today. I'm just going to go to the one that's more difficult. You can get the simple one. You're all smart, right? Yeah. Well, most of you. Anyway, so we want to find T12, and I'm going to assume this is a geometric one. So in order to find T12 over here, the formula is this: T1 times the ratio to the n minus 1 power. And we're going to need to know n, we're going to need to know the ratio, and we're going to need to know the first term. We already know what n is, don't we? It's 12. It is 12. But we're going to have to find the ratio and T1 with the information over there before we can find the 12th term. So I'm going to want T12. So we shall use this and this. Remember how we set it up yesterday? We made two nice columns. T2 is 24. And over here, we're going to say T5 is 3. And we're going to use the formula, this thing. And we're going to use the formula, this thing. Like that. And we're going to set ourselves up a little equation with this information. T2 is 24. What's your n value going to be? 2. Right? So T2 equals, don't know what T1 is, do we? No. Times R. I don't know what R is either. But I do know that n is 2. And what's the value for T2 equal to? 24. So, right here. That's the part of the equation that we're going to be concerned with. And if I simplify this, T1 times 2 take away 1. So R to the 1. This. By itself, it doesn't give us much information, but we're going to make another one over there, and that should get us what we need. So now we're going to do another one with T5. What will n be? 5. So T5 equals T1, don't know what it is. R, don't know what it is, but what's n? And what is that all equal to? What is T5 equal to? 3. So right here, that part's what we're going to be using. And if we simplify it, what is 5 take away 1? 4. So T1 times R to the 4 equals 3. And again, by itself, it's not very useful, but we're going to use these two together. Two equations with two unknowns, you should be able to solve it, right?
Yeah. Substitution.
I would, right, you're going to substitute, but with these, it's easier if you take the one with the smaller exponent on r and use that one. So we have to get, I'm going to get T1 by itself. How would we get rid of the r today? Yesterday we subtracted, but today we're going to divide by it because it's multiplied.
Divide by r t.
Oops, right, yes. Oh, thank you. Glad someone's paying attention.
Very well.
Once. So divide by r. And that goes away, and what do we get? T1, 24, divided by r. What are we going to do with that?
Plug her in.
Plug her in. Plug her in, right there. What's T1 equal to? 24 over r. So right here, 24 over r times r to the fourth. Can I put a 1 under there?
Good.
Just because that's the way I like it.
Could you cross off an r?
You could cross off an r, right. So one of these will cancel with one of those, and it'll be r to the third. So it appears as though I shall have 24r3 equals 3.
And then
Don't ask me how to solve this. That's why we did all those chapters up to now. You should be able to solve that.
no.
You've got to get the letter by itself right here, which means I have to get rid of that. How am I going to get rid of 24? Right? Right? That goes away. And do you notice over here, 3 goes in there once, 3 goes in there 8?
Yeah.
So it's actually 1/8.
And
Don't
then-
ask me how to solve that. You know how to get rid of a cube.
I don't know.
Cube roots. Shh. Shh. So r equals, what's the cube root of 1? Cube root of 8?
2.
So r equals 1/2.
Now you gotta plug that in, right?
Right. And because it's so low down here, I'm going to just rewrite this. That's what we have to plug it into. T1 equals 24. Shh.
That'd be 12.
T1, no, it wouldn't be 12. It's 24 divided by 1/2. Don't ask me how to solve 24 divided by 1/2. It's 24 times the reciprocal. So what is T1? 40. Right. Now, I've got the T1. I've got the R. I'm going to take these two and use them over here. What was R? 1/2. What was T1?
48.
So we're going to plug them in. Stop. Shh. T1 is 48. R is 1/2 to the 12 take away 1.
What?
What?
It's asking to enter a password.
It's 1, 2, 3, 4.
No, it's not 1, 2.
Is it 4, 3, 2, 1?
Not now.
Oh.
So, look up here. If we simplify this, it's 1/2 to the 11th. Pay attention for a minute. Look. Here's a common mistake. A lot of you will make this mistake if you don't pay attention. If you remember, please excuse my dear Aunt Sally. There's no parentheses, nothing to do. What comes next?
Exponents.
Right, exponents. And then multiply. But a common mistake, people write 24 to the 11th. This 48 isn't raised to the 11th, just the 1/2. But people always do half first and then raise it. You're supposed to do the exponent first. I might need help. It's 48. I'll put it over 1. What's 1 to the 11th? I can do that in my head. What's 2 to the 11th? 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Is it 2048?
Sure.
Double check.
I don't know. I'll do it. 24.
Somebody do that. It's been a long week.
Mm-hmm.
Is it?
I know that for
All
a
right.
fact.
So all you have to do then is multiply. You probably could reduce that at least by 4. 4 goes in here 12 times. 4 goes in here 5, 1, 2 times. It looks like I can keep going.
Mm-hmm.
By 4 again. By 4, 1, 2, 8. Is that as far?
You can go
No.
again.
Goes in there once. Goes, oh yeah, it is. So it's 3 over 128. So it's 3 over 128 is the 12th term.
Wow,
That's just one run?
Right, that is just one. That's why we're only going to get 28 of these today. Questions? Are there any questions? Does anyone have a question?
See a slide on.
You can shut it off.